Hi everyone, welcome back. Today's video is about similarity of triangles. So we are talking about triangles and their similarity. But before we start similarity of triangles, let us discuss about similarity in common, okay, of all the geometric figures. So talking about similarity, there is one more topic which is most of the times confused with similarity. That is yes, congruency. Congruency and similarity are two different ideas. They are very much again near to each other. See, congruency speaks about two different figures which merge into each other perfectly. They fit in each other, okay? You might have seen in our PowerPoint presentation about this. I have discussed there with some examples. See, congruency and similarity. Congruency is like I talk about, okay, there are two pens here, okay, and if you cannot make out that whether I change the pen, whether I am talking about the same one again and again or have I changed, if you cannot make out, in that case, we are talking about congruency. Similarity is a different topic. It's like the size does not matter there, the sizes may be different, but they both look almost the same. For example, if you are looking at a picture, let me take a picture of an object here, okay. Now you see the picture of the object. Now I am going to change the size of the object. Fine. So still you know that it is the same object I am talking about, but the size of the image is changing, right? In this case, the object remains same, but the size changes. We say they are similar. The images are similar. Congruent means they must not only look same, but also they fit into each other perfectly. Like the size, okay, it should be the same. The angles should be the same. So that's called as congruency. We have dealt with congruency in previous classes. So congruency, when we talk about congruency of circles, for example, circles. So what do you see there? Two circles of the same radii. Let me take some examples here. Okay, two circles. If they have the same radii, that means they are congruent. Examples. Let's talk about bangles of the same set. Bangles of the same set. If you change any alternatively, you can't make out the difference because all of them look alike, perfectly fitting into each other. That is called as congruency. All circles with the same radii must be congruent, right? Okay. Then what is similarity in circles? See, what happens in similarity is we know that all circles look alike in their shape. But imagine one of them is 5 centimeters, another one is 2 centimeters. What is the difference? They do not fit into each other, right? One is inside the other one. They are not perfectly fitting. That is example for similarity. Clear? So that was about circles. Let's talk about equilateral triangles. Equilateral triangles, for example, an equilateral triangle of size 5 centimeters. Okay. Let me take another one that's also 5 centimeters. Then compare both of them. They both will fit into each other. Then they are called as congruent. Their angles will be equal. Suppose you are comparing ABC and PQR. Angle A will be equal to angle P. Angle B will be equal to angle Q. Angle C will be equal to angle R. And the sides AB will be equal to PQ and AC will be equal to PR and BC will be equal to QR. So their corresponding sides and corresponding angles will be equal. Both are equal, the angles as well as sides. Then we say they are congruent, they fit into each other. However, let's talk about another situation where look at the triangles, one is bigger, one is smaller. Both are equilateral triangles. One is 5 centimeters, another one with the sides of 2 centimeters. They look same, right? But they are not exactly the same because they do not fit into each other. One becomes smaller, one becomes bigger. In this case, here the shapes are same, so the angles will be same. Let me take again the names ABC and PQR. So what happens? Angle A is equal to angle P. Angle B is equal to angle Q. Angle C is equal to angle R. But the sides are not equal. The corresponding sides for AB, you have PQ. They both are not equal. PQ is smaller compared to AB. Similarly, let us talk about PR, that is smaller than AC. What about QR? That is smaller than BC. So, in this case, they do not fit into each other. They are not congruent, but they are still similar. So, what can you say about these circles and triangles in common? See, the objects which are congruent, they also look similar. But sometimes the objects are similar, but they are not congruent. So, what can you say? In circles, congruent circles do look similar, but all similar circles are not congruent. Similarly, coming to the triangles, different triangles, that two equilateral triangles if you are talking about, all of them look similar, but they are not all congruent. But if you are taking congruent triangles, they will be similar, but all similar triangles are not congruent. Let's talk about other diagrams like square now, about two different squares of the same edge. For example, first one is 5 centimeters ABCD and second one is PQRS, that is also 5 centimeters. In that case, both of them will fit into each other. So let us talk about the first one. AB is 5 centimeters, PQ is 5 centimeters, sides are equal. Similarly, each corresponding sides, if you compare, they are equal. What about the angles? All the corner angles of the first one is 90 degree and all the corner angles of the second one, PQRS, is also 90 degree. So the angles are equal and the sides are equal. Means they both fit into each other. They are congruent. So I am talking about congruency. But let us talk about a square of 5 centimeter edge and a square of 2 centimeter edge. Now what happens? Now one goes inside the other. They do not fit perfectly into each other. One goes inside the other, one is outside, bigger one and so on. Another one is smaller inside, right? Here the corner angles of course are same. What are the corner angles? They are all 90 degrees. In ABCD 90 degree, PQRS also 90 degree, but the sides are not the same. AB is 5, PQ is 2, so they are not equal to each other. They are similar, but they are not congruent. So what can you say? Congruent squares are all similar, but similar squares are not, all of them may not be congruent, maybe or may not be. That's about squares. So in general, let's talk about other polygons like quadrilaterals, pentagons, hexagons, all of them we can apply the same logic. If you talk about any two polygons, what is the case? See, if all the corresponding sides match each other, they are equal, corresponding sides, let me remind you again, corresponding, okay, corresponding sides means, for example, let me draw here first. Here ABC is one triangle, MNO is another triangle, angle B is equal to angle N, angle C is equal to angle M, angle A, I am saying it's equal to angle O. In this case, let us try to understand which are equal, what sides are corresponding. See, if I talk about the angles, angle A corresponds to angle O, angle B corresponds to angle N, angle C corresponds to angle M. That is the corresponding angles which are equal. Now what are the corresponding sides? See, if I talk about AB, AB is a side which connects the shaded angle and the single line angle. This angle which I have drawn with a single line and the shaded angle. These two are connected by AB. So let us find a side which connects that single lined angle and the shaded angle in the other one. Here we go, the shaded one and the single line, that is O and N. So I can write AB corresponds to ON. They are the corresponding sides. Let's talk about the other corresponding sides. For example, BC. BC talks about a single line and a double line. So here single line and double line is MN. So we can write BC corresponds to MN. Can you guess the last one remaining? That is, yes, AC. AC is the shaded angle and the double angle. So that is AC. Here we go. So what corresponds to that? The shaded and the double here. Shaded and the double is OM. So OM is the corresponding sides. This is how we find out the corresponding sides. The side which is adjacent to two angles, which connects the two same angles, they will be called as the corresponding sides. Now, let's get back. So, talking about polygons once more. So, two different polygons. If you have to say they are congruent, you have to say, talking about congruency, the necessary condition is all corresponding sides are equal and all corresponding angles are equal. These are the two necessary conditions for congruency among two polygons. Only when we are talking about circles, we will not be judging it by the sides and the angles. We will be directly saying about radii. Try to remember this. For circles, the argument is different. The two circles with same radii are congruent. That's all.